Hello students. So any doubts? Any doubt from chapter 5? Okay. Why differentiated to get values of B1 and B3? Okay. Okay, so uh, as I said earlier regarding that question, like when we have, when we arrange, make the Routh uh, table, then we get somewhere 0. Okay, and then in order to do that, it is like a repeated root basically. Yeah, so when there is a repeated root, then what do? In order to find out repeated root, you differentiate that, and you will find again the root will be the same as earlier. Okay, so this is some sort of repeated root basically, because of that happens. Yeah. Um, okay, and again the mathematics wise, as I said earlier, this involves a little bit very advanced mathematics. Okay, so as I said in the lecture also earlier, we have to focus on the method only. Okay, without seeing why it happens. Yeah, so why you have to do that? But the other method where when you get 0, you just use epsilon, and from where there you can go ahead. So that also, like why you have to do like that also, like all those bases, basically the higher mathematics, advanced mathematics, that we never covered, that is not part of your syllabus also. Okay, so simply you can think that as a repeated root basically, and in order to get rid of so that you have only one root, you differentiate it, and from there you go ahead. So this is what is relevant basically. More than that is actually is out of the syllabus. Yeah. Okay, any other question? Okay. Okay, so uh, based on the some more lectures, I think lecture uh, 29, the two of them basically, where we 28 and 29 that we cover later on, and based on that, now you should be able to complete all the problems which we could not do earlier. Okay, and those problems are easy now. Even like earlier, the last week, we got a like a doubt. So how to find out the steady state error when, like when you have to always go to the time domain and solve. So now you understand that is not required. Yeah, so from lecture 28, 29, we explained basically the find value theorem takes care of all those things, and in order to apply that, you have to make sure that the roots are all the roots for the transfer function is has a negative real part. So you have to make sure only when it is a stable, then only you can apply, otherwise you cannot apply. Yeah. Last week I also solved the ME301. Yeah, and there I took value something like this. I say TS is equal to A over S plus A, this kind of thing. Yeah, so this makes sense. This is because the this is also first order system. So if it is a first order system, then this will like whatever you are giving here, this is also true. Yeah, if whatever you value your reference you are giving at the end, after a long time, this CS should match, means should equal to RS, or steady state error should be 0 in that case. Yeah. So what I mean to say is, you can also write the first problem. You can also write in terms of, let us say, system which has something like this: AS plus A is a transfer function of that, and then you can say there is a unit feedback loop as well. You have plus here, goes like, yeah. So and here ES, like this one. This is RS, here CS. So I'm giving you different perspective. You also think like that only. Whenever it is given as a first order system, this is also first order system only. Yeah. So instead of A, I will write K, as you know that K has the same meaning. Yeah. So we write K here, so that is a usual meaning, and the transfer function in this case becomes equal to K over S plus A divided by 1 plus K S plus A, and which is equal to K over S plus A plus K. So this is the transfer function for the whole thing, right? So this which is equivalent to this. Yeah. Okay. Now for the, I'm talking about B51. There was one comment where I said that A and what is the relation between A and A? How do you find out? Okay, so basically, if this represents a temperature which is giving you are giving as an input, and temperature which is output. Now, a good thermometer here have the output matching the input, right? So this is what is expected. Yeah. So we assume like this. Yeah. And in first order system, it will be like that. Okay. So now, if you say the error in this case, ES, error will be equal to what? So error will be equal to RS minus CS, where CS is nothing but equal to the ES times K over S plus A. Yeah, and then you can write 1 plus K S plus A ES equal to RS, and so ES will be equal to RS over this 1 plus K S plus A, right, is equal to you get S plus A over S plus A plus K RS. Okay, now from here you can find out a steady state error also. So if let us say RS is equal to 1 over S, which is the step input, unit step. Yeah. So in this case, ES becomes equal to S plus A over S plus A plus K multiplied by 1 over S, and steady state error will be limit S tends to 0 SES, right? And which is equal to limit s tend to 0, s multiplied by 1 over s. So we get s plus a divided by s plus a plus k. Yeah, and that becomes equal to a over a plus k. Only thing is, like, we are assuming that the thermometer should in long run, like if you give the output should match the input. And in that case, steady state error should be 0. And this tells you is A has to be equal to 0. Right? So in this setup, basically, a thermometer, a good thermometer will have K over S only. Right? There is no air term there. So that you have automatically, in that case, the transfer function of a thermometer, you can say, will be equal to K over S plus K. Yeah, so automatically what you get is whatever value you have here should match, should be the same. And that's what we assumed at the end. Yeah. So we assumed last time should be like this one, and finally this and this should be the same. Otherwise, the state error will be huge for the ramp input, right? So for the bringing of the ramp. Now for ramp, you can now accordingly you can find out from here the same thing you can apply here. Yeah. So for ramp input, so here I'm going to bring for ramp. So if it is for ramp, you have unit ramp, right? So unit ramp you have 1 over s square. And so ES will be equal to S plus A divided by S plus A plus K, right? And 1 over S square, and right, and where A equal to 0, right? So that's what we found out. So this becomes equal to S equal to 0. So we get 1 over S. 1 over S, and then S plus A plus K. A is 0, so S plus K only. Right? S plus K. Like this. Yeah. And okay. And then steady state error in the ramp case, S equal to limit S tend to 0, and you have S times ES is equal to S multiplied by 1 over S. So what you get is limit S tend to 0, 1 over S plus K is equal to 1 over K. Yeah, so 1 over K is nothing but the time equal to time constant, basically equal to time constant. Right, so just what you have is a different perspective of the same question. Basically, you have now looked differently. So either you can denote it as a single transfer function, which is equal to 1 over S, 1 over or K over S plus K. Either you can do like the open system, or closed system, here A equal to 0. Right? So you have like this one. So both are equivalent basically, right? So this is the only open system, this is closed system. Okay. Any question, guys? Okay. Now let's just solve the other tutorial problems, a few of them, and see. So let's look at question number 520. Okay, so B520, this will be also the repeat of what we have learned. So here it says find the range of K for stability of unity. So GS is given. It says unit feedback system. So we have kind of system. Yes, we have minus plus like this. CS, this is RS, right? Okay, and GS is given. So GS is given to be K over S plus 1 multiplied by S plus 2. And this is the open loop transfer function. So in this case, since the feedback transfer function is 1, hence the open loop transfer function is GS multiplied by 1, which is equal to GS only. Hence, you have this is open loop transfer function also. Okay, and now what is telling you is to find out the range of stability. Yeah, and how do you find out? You find out the closed loop. Yeah. Closed loop transfer function TS will be equal to simply 1. In this case, it will be GS 1 plus 1 for the GS. Yeah. So 1. This is for the feedback. In any case, like if GS is given here like this one, so this one is a feedback transfer function, and this one is feed forward transfer function, So in any case, this becomes GS 1 plus GS only, and finally, what do you get? TS is equal to K over, and you get S. So we will spell it out. So S plus 1, S plus 2 plus K, and hence we get is equal to K, and then S square plus 3S plus 2, right, plus K, which is equal to K divided by S cube plus 3S square plus 2S plus K. So this is the closed loop transfer function. So closed loop transfer function, you have, this is the characteristic equation, right? So you can write characteristic equation is QS equal to 0, and else you have 3S square plus 2S plus K equal to 0. This is what that is, right? Okay, now we have to find out the value of this. So we make a table, Q S square S to power 1 and S to power 0, right? And we write 1 here, okay, and then we have the 2 here, then we have 3 here, we have K here. Yeah. Okay, and we can find out. So we have 6 minus K divided by 3 here. So here it will be all 0. So basically here what you get is 0. Similarly here you get this multiplied by this divided minus this 0 divided by this one only. So you get K only. Okay. So this is what you have. So if you look at this one, all has to be positive. And that means condition for stability, and what you get 6 minus K over 3 has to be greater than 0, and that tells you 6 minus K greater than 0, and hence 6 greater than K, or K is less than 6. Yeah, so next is that is coming from here, and the second is K has to be equal greater than 0. Yeah, so from here and here, what do you get? K has to be less than 6, K has to be less than 6 and greater than 0. So this is the range of K for which this will be stable. So this is how you calculate. So whenever the open loop transfer function is given, from there you have to construct closed loop transfer function, just look for a keyword saying the unit feedback system. So in that case, there will be just a loop without any gain or without any transfer function here. Yeah, and then you construct and you can get the values. So this is how you can do. So any question, guys? These are not difficult actually, so if you like if you look at it, these are very easy questions. Only you have to have some fundamentals clear, that is all. Yeah. Okay, so let's look at some more. Okay, so we'll have D520 also, and the characteristic equation is given by S4 plus 2S cubed plus 4 plus K S square plus 9S plus 25 equal to 0. Yeah. So S4 2S cubed plus 4 plus K S square plus 9S plus 25 equal to 0. And we have to find out the K for V. This is a step, right? So range of K we have to find out. So we have S4, we can have S3, S square is there, S to power 1 and S to power 0 as well. Right? So we start with 1, then we have 4 plus K, and then we have 25. So 25, and then you have 2 here, and then 9 here. Then we have 0. Okay, so from here, what do you find? We find 2 multiplied by this divided by minus this. So becomes 8 plus 2k, 8 plus 2k minus 9 divided by 2. Right? Okay, so this is how we have done, like this. Yeah, divided by 2 is the value here. In this case will be 9. This will be 9 times 25. Okay, so minus 0. The 9 times 25 divided by 9. Okay, so what you get is 25. So you get here. Okay, it's done here. Now here this multiplied by this minus 50 divided by this. Okay, so we can work out here. So what do you get? This multiplied by this. Okay, so we get from here 8 plus 2k minus 9 divided by 2 multiplied by 9 minus 50 and divided by this only. 8 plus 2k minus 9 divided by 2. So that's what we get. Yeah. Okay. So we can work out here. And the value in this case will be, you can just divide here, so it becomes a 9 only. 9 minus, and we have 50. Okay, 9 minus 50 divided by 8 plus 2k minus 9 divided by 2, which will be 9 minus 100 divided by 8 plus. Here we can simplify further. So 100 and 2k minus, this is 9, so 2k minus 1. Yeah, so this is what the value is. Yeah. Okay, so we put value here, 9 minus 100 divided by 2k minus 1. Okay, here 0 and 0, so this will be 0. Okay, Here again, we multiply by this and this minus this and this divided by this itself. So we get 25. Okay. So this is what we get. Okay. So now we have to find out the range. We know that they have to be positive. So for stability, this one 2k minus 1 divided by 2 has to be greater than 0, and what that really means, k greater than 1/2. Yeah, so that's one you get. That's one. Second part is this one, 9 minus 100 divided by 2k minus 1 greater than 0, and you get 9 greater than 100 over 2k minus 1. Okay, and here we have to make some assumption. Okay, so let's say assume this okay, so this will be always true, not assumption, but let us see. If already says k greater than 0.5, if k is greater than 0.5, then this value is positive, right? So let us say the 1, for example, k equal to 1. So 2 minus 1, this is a positive value. Otherwise, this becomes, if k is less than half, then this becomes negative value. So anyway, that negative value is avoided. So basically this, since this is positive, you can multiply both the sides. So we get 9 times 2k minus 1 is greater than 100. Yeah, and we get 2k minus 9 greater than 100 over 9, and k is okay. So k is greater than okay, and that tells us k has to be greater than 100 over 9 plus 9 divided by 2, or in other words, k has to be greater than 100 plus 81 divided by 9 multiplied by 2, or k greater than 181 times 18. So this is what we get. So k can be like approach infinity, no problem. Yeah. So since this is already taken care of, this is this value is already greater than half, so hence only this will apply, and you get the answer. Yeah. You can see also here, if k is much bigger, then automatically this becomes smaller and smaller, and hence this will be maintained. Yeah. Okay. Any question here? Okay. Uh, sorry guys, I saw the comments just now. Okay, so okay, can we find those parameters like rise time, peak time, etc. for system if the input RT is not unit step function? The answer is no, because all these rise time, peak time, all those things are defined for these are the parameter defined for the unit step input only. Okay, so typically you have, as far as this course is concerned, like mostly what you see is a first order system, second order system. For that you have to find out these peak time and all those things. Yeah. So especially for second order system, and there are two things: second order system and unit step input. For those only these things are defined, like rise time, peak time, all those things, as far as your course is concerned. Yeah. So for other systems, those things are not there. They have different that like terms used. Yeah. So the answer is no. Okay, only for unit step function only it is defined. Okay, Nishant. Okay, B25. Yes, you can skip questions like B25. So since there are two ways of solving this kind of questions. One is to actually you take the second order system, like whatever you have that the transfer function, you just go ahead with this one. You don't have any matrix basically, or the state space method. Yeah. So state space basically it has in terms of all the equations you can write in terms of a matrix where the whole thing will be a first order system only, but represented by the large the higher order system also you are representing as a first order system only. You are assuming, for example, velocity also as a input, as a variable, rather than is we have usually what we have x double dot also there, then we have x dot also there, and x also there, right? Or you, instead of x you will have u displacement, for example, u double dot u. There you don't do like that. There what you do is you write as a matrix where you write that expression twice. First you say x dot equal to y, and then you define x double dot will be y dot. So you are converting that in first order system, and hence the matrix involved. So state space is in your syllabus you have only the last week probably little bit introduction, not in depth basically. Yeah. So although the all advanced control systems are more like that, where there it will be multiple input, multiple output kind of situation. For example, for aircraft system, for example, the control system, it has multiple input, multiple output. So those are advanced. But here idea is to learn the basics basically, and hence you have single input, single output. Yeah. And hence these questions such as B25 are based on those only, those the state space system, and these things we are skipping. Yeah, so we don't have to study those. Okay. Okay, got it, Ashutosh? Okay. Yeah. Okay, state space also it little bit, it has its own way, and we can cover only when we had the full control systems course. So not with half vibrations and half control, we cannot actually justify them. And in any case, if you know one input, one output very well, you can also do those, you can also study. So if we time permits, we will just quickly introduce to those things, maybe at the end, but only time permitting. Otherwise, it's okay. Yeah, so, but, later on, if you're interested, you can take during the graduate courses. So graduate course has all kind of things. Yeah. Any other question, guys? Okay, so let's look at 526. So this is B526, and here it says unity feedback control system with closed loop transfer function. So TS is given. TS equal to CS over RS is equal to AS plus B divided by S square plus AS plus B. Okay. Okay, so first it is asking you what is the open loop transfer function. So GS is what? Since it looks like this, so we have GS here and CS unit, hence you have like this minus plus RS like this. Okay, so open loop transfer function or T naught S is nothing but GS only, 1 times GS. GS like in your book, this GS is also known as the feed forward transfer function. The feedback transfer function is 1. Here is the open loop transfer function is GS multiplied by 1, and hence it is equal to GS. So TS you can write in terms of GS. TS equal to nothing, but equal to the GS 1 plus T naught S basically, which is equal to GS plus 1 plus GS only. Yeah. Okay, and this is equal to Ks E divided by S square plus AS plus B, and hence you can write GS multiplied by S square plus AS plus B equal to 1 plus GS, and you have Ks plus B, okay? And you can bring it this way, so GS S square plus AS plus B minus, so minus Ks minus B, okay, equal to Ks plus B. Okay, okay, and hence you get GS equal to Ks plus B divided by S square, then B cancels out, and you have plus A minus K S and BB. Right? So this is what the GS is. You have to get that. Yeah. Okay. Next thing is show that a steady state error in the unit ramp response is given by this. So unit ramp response. Okay. So first you have solved this one. Yeah, this is open loop. But for the in order to find out the ES, we can use make use of this. So here it will be the error, right? So ES will be equal to RS minus CS equal to RS minus, and here we have GS, right? So we have GS multiplied by ES. Okay? So CS equal to GS multiplied by ES, and so we get 1 plus GS times ES equal to RS, and hence ES equal to RS divided by 1 plus 1 plus GS. Okay? Is what you get. Okay, the poll was not clear. Okay, can you elaborate? I did not get you what you are saying. So okay, the pole basically is the characteristic equations root are basically pole. Yeah. So the pole and root are basically the same. Yeah. Okay. So okay, it comes out to be the same. So so basically the okay. Let me finish this one. Okay, and then I will talk to. Yeah. Okay. Just a minute. Okay. Just a minute. You should have asked earlier, no? Okay. Just hold on. Now. So there is also no power here. Okay, so I actually this is also getting out of battery now. Okay, so let me also connect to something else for power, and then I will resume. Just give me 2 minutes. Okay, so there is no power. Okay, so this phone is also getting out of the battery, so I have to connect it. Okay, so okay, let me finish this one first, okay, and then we will do. So basically, what we're talking about the steady state error and 1 plus GS we can so ESS is equal to for the ramp unit ramp it's asking so unit ramp the RS is equal to 1 over S square and GS is given here. So ES will be equal to, we have RS which is 1 over S square multiplied by 1, yeah, so 1 plus and GS is this and GS is KS plus B divided by S square plus A minus K times S and S will be equal to 1 over S square and then we have s square plus a minus ks, yeah, and divided by s square plus a minus k s plus k s plus b. Okay, so we have here we can cancel one of the s, so we have 1 over s, and then we have s plus a minus k divided by, and then this case gets cancelled, so s square plus as plus b, yeah. Okay, and so steady state error yes will be limit s tend to 0 s, and what you get is here s is you multiply it, so limit s tend to 0, and we have s plus a minus k divided by s square plus as plus b, and then all s these will be equal to 0, so you get a minus k over b. Okay. Okay. Yeah. Okay. So basically, yeah, we can have in next session. So Aditi, I will also explain in the today's the lecture I will record. So in that I'm going to explain it again. Okay. So that there is a no confusion. Okay. And still, if it is not clear, then we can talk next Monday. Okay, so in the next lecture I will explain again, so what is pole and what is the relation basically, so I will try to make it more clear. Okay, so fine. So okay, so actually okay, okay, so the pinning I have done already, so I don't know why it works that way, somehow so I have pinned already, but still it has problem. Okay. Yeah, so please go ahead. So Aditi, since if you have quiz, uh, so you also have quiz. Otherwise, I can explain. Yeah. Okay. Yeah. Okay. Okay. So in the video itself, I will explain that the polls, and if still there is confusion, then we will discuss in the next live session. Okay. See you guys.